Texture tiling. It's an automatic sign that an image is computer generated. It can be super easy to notice when the creator did not try to remove it. Fear not. There are a few techniques that can alleviate tiling and one that can even remove texture tiling entirely. While these techniques can vary between different software, the principles should be the same. That said, this video will cover their implementations in Unity. First, I want to talk about a solution you should not use: absurdly high resolution textures that cover a larger area than regular ones. While this seems like it might work, it just kicks the can down the road, and tiling and/or low resolution will still be visible across even moderately sized landscapes. It also increases the technical requirements of the hardware running it. If you are making environments for VR or VRChat, this limits the graphical fidelity significantly to achieve acceptable performance, especially on Quest. One solution is to use textures which do not feature much variety within the texture itself. This will reduce the appearance of tiling. Look at the difference between these textures. Clearly, there is one where the tiling is more obvious than in the other. However, this on its own will not be adequate enough for most textures and should be combined with another technique to reduce visible tiling. The exception would be for textures that have a pattern, such as tile or brick. Counterintuitively, they can look less repetitive when using a texture that is more repetitive and has less variation. Take a look at this clean brick compared to this worn brick. Since the clean brick does not have large unique areas of imperfections, its tiling does not stick out, while the worn brick does. In amateur 3D environments, I'll often see landscapes that are just a terrain with some textures on it. The problem with this is not only that it clearly showcases tiling, but also that it is incredibly unrealistic because that's not what environments are or how they look. Environments require detail, that being stuff. For landscapes, that's trees and foliage, depending on the biome. For other environments, look up reference images and then get assets based on those references. Adding objects will not only reduce visible tiling because said objects will be blocking the texture, they will also make your scene look more realistic. Remember that these tiled textures should be the foundation on which the scene is laid. They should not be the scene in its entirety. Related to the last tip is lighting. Good lighting can mask tiling surprisingly well. When the scene is lit the same way, like from direct sunlight, tiling can be painfully obvious. But when there are several lights in a scene, ideally baked lights if you're using forward rendering, and global illumination, the different gradients of the lighting can de-emphasize the textures, as they are no longer doing as much of the work in carrying the visuals of the scene. There is one way to eliminate tiling entirely, and that's by using stochastic sampling. Instead of sampling predictably, stochastic sampling samples randomly. You can see the difference between these two materials here, one with typical sampling and the other set to stochastic. The limitation with this method is that it can only be used on textures with high frequency detail, like many photorealistic terrain textures or noise textures. This will not work on textures with a discernible pattern, like bricks or tiles. Stochastic sampling is included in some community shaders like Mochi Standard for the built-in render pipeline. Enable it under the sampling mode in the material settings. Sometimes, if you have a surface which needs both small details and larger features, you can use two sets of textures, the main texture set for the big features and a smaller texture set called detail textures, usually a base texture and/or a normal map. This can be good for materials like skin or clothes where there are big features but also small patterns up close. If you're using a shader editor, such as Shader Graph, Amplify, or Substances, some of these features for reducing or eliminating tiling are available within those, in addition to generated textures such as noise. Note that substance files are not able to be used with VRChat. They would have to be baked into image textures first. Texture blending is a technique in which you can blend multiple textures together on a single surface. This can be done natively on terrains or on any mesh by using specialized shaders. The way they work is by painting vertex colors onto the mesh. Vertex colors give each vertex a color, and these are interpreted by the shader to correspond to different textures or materials. Unity's terrain tools already have a painting system, but to do this for a custom mesh, you can use Polybrush's vertex color painting feature. Link to a Polybrush tutorial in the description. Some shaders that include texture blending are most terrain shaders, Silence Filamented Texture Blending version, Oral's layered material, and shaders exclusive to their creator's Patreon, such as RedSim's splat mapping. Remember that since this technique uses vertex painting, your mesh must have enough vertices to paint on it. You can easily generate high poly planes in Unity with ProBuilder, and then add many cuts to said plane when you are first creating it. Other shaders use a mask texture to blend textures, but sometimes it is less suited to tiling textures. The Poyomi shader has an RGBA masking feature covered in this tutorial. One other more labor-intensive way to add specific details like cracks is to use decals. These are available in URP and HDRP, and in the built-in render pipeline they are called projectors. Honestly, from my testing, projectors are pretty broken for anything except blob shadows. Plus, there's hardly any documentation or tutorials about them, and they require shaders from the no longer available Unity Standard Assets 2018 package. You can still download it on GitHub repos though. There are also mesh decals, which are simply meshes placed slightly above a surface. The material is usually set to a transparency mode, like cutout or fade. There's a paid third-party solution called Decalery, made by Mr. F, the creator of the bakery light mapper. This creates mesh decals that wrap around more complex geometry. Some advantages with this are that you don't need to use special shaders and they work fine with lighting. For textures that don't have a lot of high-frequency detail, like stylized textures, you can change the default box mapping to Kaiser. What this does is makes the textures far away look sharper, because it applies a sharpening filter to their Mip maps. However, don't change the Mip map filtering to Kaiser for textures with high-frequency detail. Otherwise, it can introduce new artifacts. VRChat has a new setting that overrides Kaiser Mip mapping to Detail Preserving Image Downscaling, DPID, currently in beta. You can find it in the Settings tab of the VRC SDK window. I hope you learned something new. Thanks to my Patreon supporters as always, and thanks to you for watching.